Oxygen is a chemical element with atomic number 8. It means it has 8 protons in its nucleus. Oxygen forms a molecule of two atoms, which is a colorless gas at normal temperature and pressures. It has a symbol O. It is a member of a chalcogen group in the periodic table, a highly reactive nonmetal and an oxidizing agent that readily forms oxides with most of elements as well as with other compounds. Oxygen is the most abundant element in the Earth's crust. After hydrogen and helium, oxygen is the third most abundant element in the universe. At standard temperature and pressure, two atoms of the element bind to form dioxygen, a colorless and odorless diatomic gas with the formula O2. Diatomic oxygen has currently constitutes 20.95% of the Earth's atmosphere. Though this has changed considerably over long periods of time, oxygen makes up almost half of the Earth's crust in the form of oxides. All plants, animals, and fungi need oxygen for cellular respiration, which extracts energy by the reaction of oxygen with molecules derived from food and produces carbon dioxide as a waste product. In tetrapods, breathing brings oxygen into the lungs, where gas exchange takes place. Carbon dioxide diffuses out of the blood and oxygen diffuses into the blood. The body's circulatory system transports the oxygen to the cell where cellular respiration takes place. Many major classes of organic molecules in living organisms contain oxygen atoms, such as proteins, nucleic acids, carbohydrates, and fats. As to the major constituent inorganic compounds of animal shells, teeth, and bones, most of the mass of living organisms in oxygen as a component of water, the major constituent of life forms. Oxygen is continuously replenished in Earth's atmosphere by photosynthesis, which uses the energy of sunlight to produce oxygen from water and carbon dioxide. Oxygen is too chemically reactive to remain a free element in air without being continuously replenished by the photosynthetic action of living organisms. Another form, allotrope of oxygen, ozone O3, strongly absorbs ultraviolet UVB radiation, and the high altitude ozone layer helps protect the biosphere from ultraviolet radiation. However, ozone present at the surface is a byproduct of smog and thus a pollutant. Oxygen was isolated by Michael Sandivogius before 1604, but it is commonly believed that the element was discovered independently by Carl Wilhelm Scheele in Uppsala in 1773 or earlier, and Joseph Priestley in Wiltshire in 1774. Priority is often given for Priestley because his work was published first. Priestley, however, called oxygen as dephlogisticated air and did not recognize it as a chemical element. The name oxygen was coined in 1777 by Antony Lavoisier, who first recognized oxygen as a chemical element and correctly characterized the role it plays in combustion. As we considered Joseph Priestley as a discoverer of oxygen, He was born in 1733. Priestley was the eldest of six children. After his mother died while he was only 9, his father, a maker of wool cloth, sent him to live with his aunt. He was in his aunt's home that he was exposed to theological and political discussions, field in which Priestley would go on to play a stellar role. As in his scientific career, attending local schools, Priestley had to drop out during his teenage years with a bout of tuberculosis. He had learned Greek and Latin by now, had also taught himself a good many languages, including French, German, and Italian, and was well versed with the basics of algebra and geometry. While he enrolled himself at Daventry Academy with the objective of becoming a minister, it was here that he became engrossed in experimenting and sciences. He did become self-sufficient for the rest of his life after graduation, serving indeed as a minister, teaching modern languages, and finding himself in places where he could indulge his growing interest in scientific experimentation. His frequent visits to London brought him in touch with some of the leading minds of science and independent thought. Among them was Benjamin Franklin, one of the founding fathers of the United States, who would go on to become Priestley's lifelong friend. Franklin engaged Priestley on his research and encouraged him to further investigate electricity. Priestley duly did the same and published some of his findings in the history and present state of electricity. Not long after, Priestley was elected a Fellow of the Royal Society in 1766, as he believed that this book was quite over the top for the majority of the people. He looked to tone it down in order to make it more accessible. When he could not find illustrators to help him with this task, he took to drawing himself, managing along the way to discover an early form of eraser. Priestley's religious stand, however, came under increasing pressure. He missed out on a chance of being the scientific advisor for Captain James Cook, a British explorer, during his second voyage, but it might well have been a blessing in disguise. The Earl of Shelburne asked Priestley to serve as his intellectual companion and estate's librarian in 1773. A position that afforded Priestley the chance to mingle with the elites and, more importantly, more time for his research. On August 1st, 1774, Priestley was the lens to focus sunlight and heat a sample of mercuric oxide using a pneumatic through a laboratory apparatus. He realized that the resulting gas that he had collected allowed a candle to burn more brightly and supported the life of a mouse placed under a glass filled with it for 4 times as long as a similar quantity of air. He decided to call the resulting new air as dephlogisticated air, as he was a staunch advocate of phlogiston theory. This now defunct theory, the dominant belief in that era, postulated that phlogiston, a fire-like element, is contained in combustible bodies. We now know this gas simply as oxygen. While there were predecessors to the discovery of oxygen, including Swedish chemist Carl Wilhelm Scheele's isolation the previous year, Priestley is often credited with the discovery as he was the first to get his result published in a paper. In the years that followed, Priestley had to eventually flee England owing to his religious views and his political stance, as he supported the American Revolution and then the French Revolution, setting sail to America in 1794. Priestley continued his research with much success until his death in 1804. On discovering oxygen, Priestley wrote the following: The feeling of it in my lungs was not sensibly different from that of common air, but I fancied that my breast felt peculiarly light and easy for some time afterwards. Who can tell but that in time this pure air may become a fashionable article in luxury? Hitherto only two mice and myself have had the privilege of breathing it, while only two mice and Priestley himself had, according to him, breathed pure oxygen up until that time. His prediction that it might turn out to be a luxury commodity might as well come true. What with air purifiers for rooms and living spaces, luxury air and mountain air being sold in cans, we are closer than ever to what Priestley envisioned. One only hopes that pollution does not drive air quality so low that buying air to breathing becomes the norm in the future.